Welcome to Flokel Show, a show that informs, shares and educates. Today, viewers, I'm looking at event-driven programming, and I will just start by the introductory part of it. And I'm saying that event-driven programming is a paradigm where the flow of program is determined by events, actions or occurrences such as user interactions, clicks, keystrokes, messages from other programs or sensor outputs. Unlike traditional programming, where tasks are executed in a set sequence, event-driven programming allows a program to respond to events as they occur, often out of order. Then I'll look at simple concepts which normally occur in event-driven programming, and some of the concepts which we have. The first one is event, and these are actions or occurrences that the program responds to, like a button click, file update, or a network request. The other terminology that we have is event handlers, and these are functions or methods that are triggered when a specific event occurs. Each event handler is associated with a particular type of event, like an on-click event handler. Then the third concept that I will look at is event loop, and this is a programming construct that waits for and dispatches events or messages. It continually checks if there are any events that need to be handled, and if so, routes them to the appropriate handler. Callback functions is the next concept, and these are functions that are passed as arguments to be executed later, usually in response to an event. And the last term I will look at is listeners, and these are constructs that wait and listen for specific events to occur. When an event occurs, there is a triggers the associated handler. I welcome you to Flokel Show, the show that informs, shares and educates. In Flokel Show we will learn a lot, and today we want to look at advantages of event-driven programming. As you are aware, event-driven programming is a paradigm in which the flow of the program is determined by events like user actions, clicks, key presses, sensor outputs or messages from other programs. It's particularly suited for interactive applications such as graphical user interfaces, games and real-time applications. Here are some of the advantages of event-driven programming. The first advantage we have in event-driven programming is that it has enhanced interactivity. Event-driven programming allows applications to respond to user inputs like clicks, typing and gestures in real time. This interactivity enables applications to be highly responsive to user actions, making them more engaging and user-friendly. This is essential for graphical user interface applications where users expect immediate feedback from the interface. The second advantage we have with event-driven programming is modularity and reusability. Event-driven programming promotes modularity by separating the code into small, independent event handlers or functions for specific events, e.g. button clicks or window resizing. This makes the code easier to organize, test and maintain. Because event handlers are modular, they can often be reused across multiple parts of an application or in different applications altogether. The third advantage of event-driven programming is flexibility and scalability. Event-driven applications can be easily scaled by adding new event handlers or modifying existing ones without affecting the entire program flow. Developers can integrate new features such as additional controls or actions without major changes to the core logic. The flexibility to respond to different events makes it easier to adapt event-driven applications to new requirements or user needs. Advantage number 4 for event-driven programming is that it has better user experience. Applications that respond immediately to user actions improve the overall user experience by providing instant feedback. And this is especially important for applications with complex expressions like software for design, gaming, or real-time applications. Event-driven systems can handle events asynchronously, meaning that users do not have to wait for certain processes to complete before performing other actions. Then advantage number 5 is that event-driven programming is easier to understand and maintain. Event-driven programming organizes code around specific actions, which make the logic straightforward and easy to follow. This modular approach reduces code complexity as each event handler is focused on a single specific task. When a bug occurs in a particular feature, it's often isolated to a specific event handler, making it easier to locate and fix. Advantage number 6 is that event-driven has efficient resource use. In event-driven programming, code is only executed in response to an event, which can save system resources because the application does not constantly poll for changes or run unnecessary code. Applications can sleep or remain idle when no events occur, saving CPU and memory until they are needed. This is especially beneficial in mobile and embedded systems. Advantage number 7 of event-driven programming is the issue of parallelism and concurrency. Many event-driven systems support asynchronous execution, allowing events to be handled in parallel or concurrently. This is particularly useful for web applications where multiple requests from different users need to be managed simultaneously. Event-driven programming is also suitable for handling multiple input streams or events, such as messages in a networked application, concurrently enhancing performance and responsiveness. Advantage number 8 of event-driven programming is that it has better real-time processing. Event-driven programming is ideal for real-time applications, e.g. financial trading platforms, where fast response to external stimuli is required. The ability to respond to events as they occur without waiting for other tasks to complete makes event-driven programming well suited to real-time applications. Advantage number 9 of event-driven programming is simplified error handling. By isolating different actions into separate events, error handling can be simplified. Errors are often contained within specific event handlers, which can handle exceptions without affecting the rest of the program. This reduces the risk of cascading errors that might impact the entire application. Then the advantage of event-driven programming number 10 is that it is suitable for distributed and networked systems. Event-driven programming is highly effective for distributed and networked applications where events are generated from multiple sources, e.g. user input, network requests, external devices, etc. Event-driven architectures support asynchronous communication, making it easy to manage multiple sources of data or requests as in web servers or cloud-based applications. However, event-driven programming has a few disadvantages, and one of them is complex debugging. Because events can occur at unpredictable times, tracing the program's flow can be challenging. Event-driven programming has higher memory usage, and keeping multiple listeners active can consume more memory, particularly in resource-limited environments. Thank you for listening to Flockel Show. We are a show that informs, shares, and educate. We shall proceed from there next time.